This video is going to show us how to do a confidence interval for the difference of two proportions, and we're using the same example we did in the hypothesis test video. And so confidence intervals, again, are we're trying to take a sample and make an inference to the population. So back in the hypothesis test, we assumed that there's no difference between these two groups, or whatever two groups we're studying, in this case treatment and placebo. The proportion in the treatment, the proportion of the placebo group are going to be the same. But the question is, based on what we've observed, what do we think the true difference in these proportions are? So we're going to do a 95% confidence interval. And again, we're not going to use the pooled method. We're just going to use the straight P1 and P2 hats. Remember, Q1 and Q2 are just 1 minus P. So in this case, P1 hat was 100 divided by 1,000, so it's 0.1. So P1 hat is 0.1, and that means Q1 hat would be 0.9. So there's the formula for our formula sheet. I'll pull up the formula sheet. Again, our first question is confidence interval or hypothesis test. We're going to do a confidence interval here. And there it is, confidence interval for proportions, and then confidence interval for the difference of two proportions. So the first question, yes, it's confidence interval. Second question, is it means or proportions? It's proportions. And the third question is there one or two samples? So there it is. We're going to use that one. If we go back to the notes here, so we just take the difference between the two samples, and this one's 0.1, and this one's 0.125. So we take 0.1 minus 0.125. So we've observed a difference of about 2.5% between the two, and then we go plus or minus, and then our z multiplier. And since it's a 95% confidence interval, and the reason I picked that is because we have an alpha level of 0.05, which means our confidence interval would be 95. So we use 1.96. It's the same ones where you get your multipliers, right here, 95%. There it is when we're using z, 1.96. And then this is our standard error measurement, which is the same one we used for the hypothesis test. So it's just P1 hat, Q1 hat divided by N. This is P2 hat, Q2 hat divided by N. So we calculate this margin of error right here is about 3.5% margin of error, which means if you add and subtract 3.5% to negative 2.5%, you get negative 6% to positive 1%. So to state what this means in English, it means we are 95% confident the true difference in population proportions is between negative 0.06 and positive 0.01%. And so remember, we're just saying, where do we think the true difference lies? It's somewhere in this interval. And since 0 is in this interval, it is conceivable that there really is no difference in these two population proportions. So this kind of backs up what we did in the hypothesis test, which also we declared that we didn't have enough evidence to say that there was a significant difference between these two population proportions. So there's a 95% confidence interval for the difference of two proportions.